Hi, I'm Linda from English Learning Mind Map. Today, we will learn about empirical inquiry. Empirical inquiry. To shed light on the mysteries of nature and break new ground through empirical inquiry, researchers follow a strict process. Basically, we are using scientific idioms to describe how discoveries are made. Experimental design. As a core pillar of empirical inquiry, experimental design helps to lay the groundwork and set the stage for a valid test. In simple terms, you are preparing the plan so the experiment is fair and accurate. Controlled variables. Controlled variables are a branch of experimental design used to rule out interference and keep a lid on outside factors. This means making sure the room temperature or light doesn't change and mess up your results. Baseline establishment. Within baseline establishment, scientists often start from scratch to ensure they can hold steady during the measurement process. To put it simply, you begin with a clean slate and make sure your starting numbers don't move. Procedural fidelity. Procedural fidelity serves as a functional layer of experimental design to go by the book and leave no stone unturned. Essentially, you are following the rules exactly and checking every tiny detail of the process. Systematic replication. Through systematic replication, other teams follow suit to do a carbon copy of the original experiment. In other words, they do the exact same test again to see if they get the same answer. Data interpretation. Data interpretation is a vital branch of empirical inquiry used to make heads or tails of the results and read between the lines. Basically, you are trying to understand what the big pile of numbers is actually telling you. Statistical significance. Statistical significance is a core part of data interpretation where you check if your findings are on the mark and hold water. This means using math to prove that your discovery is real and not just a lucky guess. Correlation analysis. Within correlation analysis, we see how different factors go hand in hand and try to point the finger at the cause of a change. To put it simply, we look at things that happen together to find out who is guilty of causing the effect. Anomaly detection. Anomaly detection serves as a functional layer of data interpretation to spot a red flag when something sticks out like a sore thumb. In short, you are looking for a weird number that doesn't fit with the rest of the group. Outlier evaluation. During outlier evaluation, scientists take with a grain of salt any result that seems to throw a curveball into the theory. Effectively, you don't believe the strange data immediately because it was totally unexpected and might be an error. Peer scrutiny. Peer scrutiny is a critical requirement for empirical inquiry to pick holes in a theory and put through the ringer every new claim. Effectively, other experts look at your work very carefully to try and find any mistakes. Blind review. Blind review is a strategy within peer scrutiny where reviewers call a spade and play it safe to avoid bias. This involves experts giving their honest, blunt opinion without knowing who wrote the paper. Anonymized assessment. Through anonymized assessment, we keep in the dark the identity of the author to level the playing field for everyone. Simply put, we don't tell the judge your name so that every scientist gets a fair and equal chance. Critical feedback. Critical feedback is a technical application of peer scrutiny used to get down to brass tacks even if it might touch a nerve. In simple terms, you are talking about the most important, difficult facts, even if it hurts your feelings. Rigorous revision. To achieve a rigorous revision, one must often go back to the drawing board to iron out the flaws in the study. This means starting the plan over from the beginning to fix the small problems the reviewers found. Dissemination of findings. Dissemination of findings is a fundamental goal of empirical inquiry to spread the word and hit the headlines with the news. Basically, you are telling the whole world about the amazing thing you discovered. Public outreach. Public outreach is a core part of dissemination of findings used to bring down-to-earth complex ideas and bridge the gap with the public. This means explaining hard science so that normal people can understand it too. Science communication. Through science communication, experts put in a nutshell their work so that everyone can speak the same language. In other words, you explain the whole project in a few simple words so you can talk to people who aren't scientists. Scholarly publication. Scholarly publication is a practical goal of dissemination of findings where a paper will finally see the light of day and make a splash. Essentially, your work is finally printed in a big magazine and everyone is talking about it. Impact factor. Under the umbrella of impact factor, certain journals carry weight because they set the bar for scientific excellence. To put it simply, some science magazines are very important because they have the highest standards in the world. Thanks for watching. Please like and subscribe for more English lessons.